In this video, we will be continuing to go through the College Algebra Unit 4 exam on polynomials, but this video will go through the back of the exam. So part 3 tells us to solve each equation below by factoring. So you'll notice in both of these problems, 9 and 10, there's an equal sign indicating that it's an equation, and what we're trying to do is solve for n, solve for r. So the first step in number 9 is we need to get that 6 over to the left side of the equation so that this equation is set equal to 0. We're going to bring down the n squared, bring down the 3n, and combine negative 12 minus 6 is negative 18. This is now a trinomial that can be factored. We're going to look for two factors that multiply to negative 18 that also add to positive 3. So when we think of the factors of negative 18, it's either going to be 1 and 18, one's positive, one's negative, 2 and 9, one's positive, one's negative, or 3 and 6, one is positive, one is negative. When we look through our choices, we want them to add to positive 3. That's going to be the minus 3 and the positive 6. So this now gets factored into n and n, minus 3 and plus 6. Don't forget to bring down the equal 0. This is an equation. We can't lose the right side of this equation. Then this means that we have two possible outcomes, either n minus 3 equals 0 or n plus 6 equals 0. So we want to solve both of these simple equations and get n equals 3 and n equals negative 6. So these are our two solutions. If we check n equals 3 and n equals negative 6 in the original equation, they will both come out to be true. Another way we can write this answer is using set notation. So n equals the set of numbers, including negative 6 and positive 3. In number 10, we notice that this equation is not set equal to 0. So the first thing that I'm going to do is add 30r to both sides so that this equation can be set equal to 0. I'm going to bring down any terms that cannot be combined with anything, and I am going to combine the terms that can be combined. This gives us a positive 150r. Now we need to factor this trinomial. The first thing I notice is that there is a GCF. All three of those terms have a 5 in common, and all three of those terms have an r in common. So let's go through and divide out the GCF in each term, but we have to remember that GCF is still part of the left side of this equation. So when we divide here, we get 1r squared, or just r squared, minus 11r plus 30. Don't forget the equals 0. Now, this is a trinomial that can be factored more. We're going to look for two factors of positive 30 that add to negative 11. So we know that these both have to be negative. Negative 1 and negative 30 doesn't work. Negative 2 and negative 15, no. Negative 3 and negative 10, no. Negative 5 and negative 6, yes. Those add to our negative 11. So we're going to keep our 5r GCF out front, keep our equals 0. This trinomial is now getting factored into r and r, minus 5 and minus 6. Now we actually have three solutions. We can set 5r equal to 0, r minus 5 equal to 0, and r minus 6 equal to 0. Dividing by 5 gives us r equals 0. Adding 5 gives us r equals 5. And adding 6 gives us r equals 6. So there are actually three solutions here. R equals the set of numbers including 0, 5, and 6. Part 4 of this test says, show all work to solve the word problems below. Only an algebraic solution can be eligible for full credit. And then it goes through the point values. Let's take a look at number 11. The square of a number is 70 more than triple the number. Find the possibilities for the number. So what we're trying to solve for is this unknown number. So I'm going to first use a variable to represent the number. I'm going to use x to represent what we're looking for. So I'm going to go through and translate piece by piece here. The square of a number, that's our number squared, or x squared, is indicates equals in this case. 70, of course, means 70. More than is indicating addition. Triple the number means 3 times the number, which I'm referring back to my x, which is representing the number. So this is our equation. If you can set up this equation, the rest of this word problem is not a word problem at all. It's just algebra. So what we want to do to solve this equation is start by moving all of our terms over to one side. I am going to suggest here that we keep the x squared on the left side because we would like it to stay positive if possible. So as I'm going through these steps here, I end up with a trinomial x squared minus 3x minus 70 equals 0. That can be factored. So what I want to look for are two numbers that multiply to negative 70 that add to negative 3. With a little bit of investigating, I am going to find that that's 7 and negative 10. So I'm going to come over here to continue my work. I now have x and x, positive 7 and negative 10. Don't forget that this is equal to 0. What that allows me to do is set the x plus 7 equal to 0, giving me a solution of x equals negative 7. And it allows me to set x minus 10 equal to 0, giving a solution of x equals 10. So the question says find the possibilities for the number. The possibilities are negative 7 and 10. Well, we read the length of a rectangle is 2 inches less than twice the width. If the area of the rectangle is 112 square inches, find the dimensions of the rectangle. So finding the dimensions of the rectangle means we want to find the length and the width. So we need to translate what the length and the width of this rectangle should be. Because this first sentence states that the length is based on the width, I'm going to use regular x to represent the width. And the length is 2 inches less than twice the width. So twice the width is 2 times x, but 2 less than that is minus 2. So 2x minus 2. Because we know our formula for the area of a rectangle is length times width equals the area, I'm now going to multiply the two dimensions, length times width, in either order, and set it equal to the area, which we know is 112. What we end up with here is an equation that can be solved. We'll start by distributing. X times 2x is 2x squared. X times negative 2 is negative 2x. Bring down the equals 112. I do want to get all of my terms over to one side and get this set equal to 0. And what I notice is that there's a GCF here. There's a GCF of 2. And when I divide out that 2, keeping the 2 out front, but dividing it out, I get x squared minus x minus 56 equals 0. So now I'm keeping the 2 out front, but I can continue factoring that trinomial. I'm going to be looking for two numbers that multiply to negative 56 that add to negative 1. So I'm going to go off to the side here, and with a little bit of investigating, we find that the numbers we're looking for are negative 8 and positive 7. So this is going to be x and x, minus 8 and plus 7. So what that allows us to do is set each of these factors equal to 0. 2 equals 0 doesn't make sense. There's not even a variable there, so that does not give us a solution. X equals 8, set equal to 0, gives us a possible solution of x equals 8. And x plus 7 set equal to 0 gives us a possible solution of x equals negative 7. Because we're talking about the length and the width of a rectangle, a negative answer is not going to make sense. So we're going to want to go with the x equals 8, which tells us that our width is 8, and inches are our units here, and our length is going to be 2 times 8 minus 2, which is 14 inches. So to make my answer very clear here, I'm going to rewrite that the length in this case is 14 inches and the width in this case is 8 inches. Final answer here. In number 13, we read, suppose that the sum of the squares of the three consecutive positive odd integers is 155. And we need to write the correct equation for this scenario. The rest of this just talks about how to receive extra credit. We're not actually going to solve this, we're just going to be setting it up. So suppose that the sum of the squares of three consecutive positive odd integers is 155. Is 155 is going to be equals 155. When it talks about consecutive positive odd integers, this is where we want to use x plus 2, and x plus 4 to represent our first, second, and third consecutive positive odd integer. So when it talks about the sum of the squares, we're going to take our first integer and square it. Sum means add. We're going to add that to our second integer squared and add that also to our third integer squared. This is the equation that would be solved to give us our solution. However, we don't actually have to solve this one, but this is the setup that would receive full credit on this problem.